Good day everyone, this is Bryan Cunanan, taking up a bachelor's degree in secondary education with a major in mathematics at Nueva Ecija University of Science and Technology San Isidro campus. So for this video, I'm going to discuss Euler's theorem. But before I discuss the definition and example of this theorem, let's first discuss its founder. So who is the founder of Euler's theorem? This theory is credited to Mr. Leonhard Euler when he solved the problem of the Greenwich Bridge. He was born on April 15, 1707 in Basel, Switzerland, and died on September 18, 1783 in St. Petersburg, Russia. A Swiss mathematician, physicist, astronomer, geographer, logician, and engineer who pioneered and impacted a number of mathematical areas, including analytic number theory, complex analysis, and infinitesimal calculus. Moreover, Euler was a talented mathematician who contributed to the geometry, calculus, trigonometry, algebra, number theory, physics, lunar theory, and even astronomy. Additionally, Euler's is considered one of the finest mathematicians of all time by his contemporary colleagues and even by mathematicians working nowadays. And now, let's define Euler's theorem. So what is Euler's theorem? Euler's theorem states that if GCD is A and N is equal to 1, then A to the quotient N power is congruent to 1 mod N. So here, quotient N is Euler's totient function, the number of integers in set 1, 2, and so on until n minus 1, which are relative prime to n. When n is a prime, this theorem is just a Fermat's little theorem. So before we proceed to the examples, I just want to say first that Euler's theorem has a 4 rule, and that are rule number 1, p minus 1, where p is a prime. Rule number 2, p to the n power minus p to the n minus 1 power, where n is a prime power. Rule number 3, the quotient m multiplied by the quotient n, and that's the rule number 3. And the last rule is the most applicable rule, which is rule number 4. N times the quantity of 1 minus 1 divided by p sub 1 multiplied by the quantity of 1 minus 1 divided by p sub 2 multiplied by the quantity of 1 minus 1 divided by p sub k. So, and now, for us to have a better understanding with this, let's give some examples. Let's say we have 11 to the 109 power mod 21. The first thing we need to do is to find the factor of 21, and that is 3 and 7. Because both 3 and 7 are prime numbers, we can use the rule number 4, and that is n multiplied by the quantity of 1 minus 1 divided by p sub 1 multiplied by the quantity of 1 minus 1 divided by p sub 2 multiplied by the quantity of 1 minus 1 divided by p sub k. Now, let's substitute the given variables. So, we have 21 multiplied by the 1 minus 1 divided by 3 multiplied by the quantity of 1 minus 1 divided by 7. If you can see, we use the denominator 3 and 7, and that's the factor of 21. So after that, we need to simplify. So we have 21 multiplied by 2/3 multiplied by 6/7. And now our quotient now is 12. And because we have 12 as a quotient, let's use it. So 11 to the 12 power is congruent to 1 mod 21. So after that, we need to divide 109 to 12. So we have 11 to the 12 power to the 9 power, because 109 divided by 12 is 9, and we have remainder, so multiplied by 11 to the 1 power is congruent to 1 multiplied by 11. So and now the answer now is become 11 mod 21, and that's the example of Euler's theorem. So let's go to another example. Let's say we have 13 to the 193 power mod 35. Because the factors of 35 are 5 and 7, so we can use the rule number 3, and that is the quotient m multiplied by the quotient n. Let's substitute all the given variables. So the quotient 5 multiplied by the quotient 7. After that, we can apply the rule number 1 to solve it easily. So the quotient 5 minus 1 multiplied by the quotient 7 minus 1. So simplify, and now we will get quotient 4 multiplied by the quotient 6. So the answer, it will become quotient 24. And because our quotient now is 24, let's use it. So 13 to the 24th power is congruent to 1 mod 35. So we need to divide 193 to 24, and it will become 13 to the 24th power to the 8th power, because 193 divided by 24 is 93, and we have remainder, so let's put it. So multiplied by 13 to the first power is congruent to 1 multiplied by 13. So our answer now is 13 mod 35. And that's the definition and example of Euler's theorem, and this is the end of our discussion. Thank you for watching. Hope you learned.